Okay, guys, this is the lesson for when I am not here. I try to keep it short. You should have picked up your pink packet from the tall table before you start this. You can see that this is our calendar of events. You guys will be taking your test on the 19th. Right here is when you're going to be taking your test. And then we have an activity after. This is all your due dates, just like it was listed last time. So we're just going to get started with our 3.1 notes, factoring using the distributive property. The width of this soccer field can be represented by x, and its length is x plus 75. And the area of the field is x plus x parentheses x plus 75, or x squared plus 75. So what we have is the product right here. This is the product. Remember the product of the area? And then this is the sum of the area. Well, we can write them equal to each other in any order. And it just helps us know that we can go back and forth between the sum and the product of the areas. And the reason we can do that is because the sum of the area is always equal to the product of the area. They're just written in different forms. The product is the two factors, the length and the width, and the sum is when we add up all the things inside our box. The expression x parentheses x plus 75 is called factored form, and that's what we're going to call it from now on. It's just with the two, the length and the width. They are the factors of x squared plus 75x. A polynomial is factored when it is expressed as the product of a monomial and a polynomial. So in the last unit, we multiplied upon a polynomial by a monomial using the distributive property. I'm sure you remember this. We use it by arrows, although we've also done it by the box. You can also reverse this process and express a polynomial in factored form by using the distributive property. This is just a recap of what we did into 2.3 lesson. So we just multiply the length and the width of each of our boxes. 2 times 3 is 6. An A, 3 times B is 3B. So when we multiply it, that will give us our area as a sum. We add 6A and 3B. Okay, when we factor it, remember this is our area as a product. And when we factor it, that's just the length times the width. It's the two sides of the box. We can do these with this. We can do it with the other two examples. So 5x times 3x is 15x squared. When we multiply the x's, the exponent changes. Then we have 5x times negative 4y, and we get negative 20xy. So our multiplying polynomials, or area as a sum, oh, I wrote a 15. 16, oh, it is 15, Ms. Stone. 15x squared minus 20xy. And our factored form is just 5x times 3x minus 4y. That's what we started with here. And we're going to do it one last time. So 3 times x squared is 3x squared. 3 times 5x is 15x. And we add them together to get the area. The multiplying polynomials and the factoring is just the two sides. And then just as a review, more things that when we did it, the first thing you need to look for is don't forget before we factor is we need to be in standard form. If you've forgotten what that is that we need to have the highest exponent. See how I have a 2 and a 2 here, but here I have a 1 and a 2, or a nothing and a 2. So this is not in standard form, so I need to rewrite it and put the thing with the highest exponent first and the thing with the next highest exponent next. So we need to rewrite it like this. So then we can draw our box. We can put both terms in our box. Okay, and then remember right here is where we're going to put our greatest common factor. This thing's negative. So we need to pull out a negative number. The greatest common factor between 18 and 12 is 6. And then I can, if you don't remember how to do the variables, I can write them out. So for the first one, I have MM, NN, and then I've got my 18. For the 12, I've got one M and two, there's an M, and two N's. So I can look at how much I'm going to circle for each. I can circle one M in both. I can circle 2 n's in both. That makes my greatest common factor be 6mn squared. Then I'm just going to use that and divide to find the other side of my box. So negative 18 divided by negative 6 is 3. M squared divided by m is just m. And n squared divided by n squared is 1, so I don't need to write it down. Not a plus sign. 12 divided by negative 6 is negative 2. M divided by m is 1. N squared divided by n squared is 1. So now I write it in my factored form with one side of my box being multiplied by the other side of the box. The parentheses show up. Okay, this other one is also not in standard form. Here's my 2. I have a 2. I need to put my 15a squared c first. The other ones don't necessarily matter in the order because they both have an exponent of 1. So I'm going to put all 3 terms in my box this time. 15a squared c, 20abc, and negative 5ac. My greatest common factor, I look at the numbers first. 15, 20, and 5 is 5. My first term is positive. All the terms don't have a b, so I'm not going to take out any b's, but all the terms do have one a and one c at least. So then 15 divided by 5 is 3. A squared divided by a is a, and c divided by c is 1, so I'm done with that term. 20 divided by 5 is 4. A divided by a is 1. The b is left. The c also is gone. Then we have negative 5ac divided by positive 5ac, which will leave us with negative 1. So we have slightly longer factor this time. We just write all the terms. The 1 has to be there because we started with a trinomial. If you remember, that means 1, 2, 3 terms, and we need to end with a trinomial 1, 2, 3 terms. All right, so that's just a review of what we did in the last unit. Now we're going to get to the new stuff. This is called factoring by grouping. So just as we can do it with a monomial and a polynomial, we can do it if we have more factors than that. So sometimes when we have 4 or more, we like to look at them and try a method called factor by grouping. So first I want to just remind you that when we have factored form, we can turn it into standard form or the multiplying form by putting the length or the first parentheses on one side of the box and the width or the second parentheses on the other side of the box. And then we multiply all the individual areas. So 3a times 4c is 12ac. 2b times 4c is 8bc. I just list those variables in alphabetical order. 3a times 7d is 21a and d. And 7d times 2b is 14bd. Now remember that this right here tells us that we need to add to get our sum of our areas. So we're going to do 12ac plus 8bc plus 21ad plus 14bd. Now this is our answer, and it is very long and it has 4 terms, but none of those terms have the exact same variables or exponents. So because they're different, we can't combine them, and that ends up being our answer with 4 terms. So our product of 2 binomials results in something with 4 terms. We can reverse this process to fact the 4 terms into binomial factors. We call this method factor by grouping. That's what the title of this section of our notes was called. Okay, so the first thing we're going to do is I have 4 terms. I'm going to draw a box, and I'm going to put the first term in the top left box, and then the second term, and the third term, and the last term always goes in your bottom right box. Here the order does matter, and we do need to put that the first term has to go here and the other one has to go here, and I just fill them in order because that's what's easiest for me. So then what I'm going to do is find some greatest common factors. First I'm going to look at this row right here. So just in that row, the greatest common factor, remember it can be more than just numbers, so we're going to have a greatest common factor of x squared there. Then I'm going to look at this row right here and the 3x and the 15. My greatest common factor is 3. Now I'm going to look at the first column. So the greatest common factor of x cubed and 3x is x. They both share an x. And lastly, I'm going to look at this last column right here, the 5x squared and the 15, and their greatest common factor is 5. So then we just write the factors. It doesn't matter which order you put them in. You could put the side first. I put the top first, but you can change it. Okay, then we can actually use this method to check all our work. And what I'm going to do is just draw another box down here. So I have my box, and this time I'm going to switch it up, and I'm going to put what I had on the side of the box on the top, and what I had on the top of the box on the side, and I'm just going to show you that we get the same answer when we've done this correctly. So I'm going to multiply the areas just like I did up above. So x times x squared is x cubed. X times 3 is 3x. 5 times x squared is 5x squared. And 5 times 3 is 15. So what you can do is now we're going to add those things together, and I want to put them in standard form. So my highest exponent is going to go first, and then my next highest exponent, and then my last highest exponent, and then the constant goes last. Now you will see that this number and this number, hey, they match. I did my check. All right, so we're going to look at example number D now. So I'm going to start and I'm going to draw my box. And I put my first term in the top left, and then my second term, and my third term, and my last term. And I am going to do the same thing I did before. I'm going to look for the greatest common factor of these two things. The greatest common factor of 10 and 12 is just 2. The first thing I see is positive, so I take a positive out. Then I have x cubed and x squared. We can take out an x squared. Then I'm going to look at this next row, the 15x and the squared disappeared. 15x and 30, they share a 15. Okay, now I'm going to look at this first left column when I do it, and the 10 and the 15. I can take out a 5 as the greatest common factor. The x cubed and the x, I can take out an x. Now I want you to notice that I don't have to draw another box to check. If I just want to double check what this one is, I can multiply 2x squared and 5x, and when I multiply them together, I get 10x cubed. And that box checks out, and I can do it all the way around. The cool thing with that is it can sometimes help you figure out what the greatest common factor is. So if I know that 2x squared is one of the sides of my box, and I maybe don't know what negative 12 divided by 2 is, or I don't know the greatest common factor between negative 12 and 30. I'm not sure if it's 2 or 4 or 5, or I just don't know. So I could divide that like we did when we did the things with the last unit where we're just pulling out the greatest common factor. Or I can look at the negative 12 and the 30 and realize that the first thing I see is negative, and then 12 and 30 share a greatest common factor of 6. And now I have my two factors. 2x squared plus 15 is one of my factors, and then I put the other factor, 5x minus 6, and they both go in parentheses. So that was just a really short version of what we're going to be doing in today's homework. There are 4 examples left. What I would like you to do is go ahead and try 3 of them, and then you can look at the notes key that's posted on Canvas and see if you understood what was going on. Go ahead and move on to your homework when you're ready. Thanks so much for watching the video.